Today's guest is Anzo, a gold medalist in the International Mathematical Olympiad and currently an MIT PhD student. Anzo's journey is not just about his impressive achievements, but perhaps most notable is his jump from honorable mention in his first participation in the IMO to a gold medal. Today we discuss the actions that he needed to take to make this leap, his strategy to preparing to the IMO, advices to young students, and his university admission. So
Yeah.
you said that when you were in China, you were supposed
Yes.
to answer 100 questions in under 4 minutes.
Yeah. So that was
Do you have any rituals before the exam?
probably just meditation.
So I said, how many hours would you spend working on math Olympiad problems, whether you are in a holiday or going to school? Is there a specific way to measure progress apart from being able to solve harder problems? Can you provide a brief background about who you are and what you do?
Okay. So yeah. As you know, I'm Enzo. So I did the IMO from 2011 to 2014, and I got a gold medal in 2014, and then after that, I did my undergrad at the University of Waterloo, which I got a degree in computer science and pure math. And now I'm a second year PhD student at MIT in the computer science department.
So I will go back to the start of how you got
Okay.
involved with mathematics. When and how did you first become interested in mathematics? And were there any early experiences that particularly impacted you?
All right. So I think okay. I'm not sure how this influenced, but then when I was very young, like I think when I was 6, I spent around 2 years in China because of my dad's occupation over there, and then I got immersed with the way how the Chinese students do math, or rather how the students in the Chinese International School do math. So it does, to my knowledge, it does seems like Math Olympiad was part of the curriculum, even though that might look very basic, but it's still pretty. It is still like higher than the what a typical school would teach. And also they have they have this like quiz on like getting you to do like the basic arithmetic in like very quickly. So like let's just say like 4 minutes you have to do 100 of them. So that kind of gave me like an exposition on how math olympiad, or rather math that is higher than typical school curriculum would look like. And after that, when I was in elementary school in Malaysia, I uh, I didn't know I didn't really got like really interested into math at that point. It's just that my teachers and my parents, they got me to like just do some math competitions just for fun, and then I just did pretty well at that. Like by math competition I mean like school math competition, some other regional things like the Australian math competition, and the one that is that is like just local to my area, and I did pretty well in them. So that's from the point where I noticed that hey, perhaps I'm good in math, and that's and also probably the more notable one during my elementary school was the Asian Pacific Math Olympiad for for primary school. So yeah, that's I was called to do the invite like the final round in Singapore two times, and I got, and then for the second time I did get like a good result. I think like top 40 award or something like that. It's not very big, but it's still something for me that time. And finally, when I was in, I think like a middle school, like grade 8, that's the first time I got into the actual math olympiad by doing the national math olympiad, and that's the time and at that time I was pretty I was still pretty green, pretty new in what the actual math Olympiad was, and 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 I just got pretty lucky that I was called to after the competition. I was called to do another extra test, and subsequently got into the IMO training camp. And I feel that that was the turning point for me, where I got exposed to the like a lot more knowledge, like including proof writing. So that was also the first time I learned how to learn how to write a proof, and that's what stimulated me to actually do math olympiad. So that's kind of like the backstory of me.
That's pretty cool. I will go back to some points that you mentioned. So
Yeah.
you said that when you were in China, you were
Yes.
supposed to answer 100 questions in for under 4 minutes.
Yeah, so that was the yeah, but these are the basic arithmetic question, like I think like one plus, okay, maybe not one plus two that simple, maybe things like 7 times 8, and then you're just supposed to like answer it very quickly. I think the point is that is to make sure that you don't have to count with your fingers.
Uh, and was that at what age?
I think that was like grade one, or at most grade two.
So what
So
is the
that's like
equivalent?
I
The
think
age equivalent?
like let's just say like 7.
Okay, because the results of China during its history in the IMO is so impressive, as
Yes.
if they have their own Olympiads, which is harder than the IMO itself.
Yes.
Um, how would you explain that? Is it like the culture that starts from the elementary school with such very hard and challenging problems, and then goes to
Yeah.
high school with even harder problems?
Yeah, I think they do have there are multiple factors for sure. So first of all, it's the population. They just there are so many talented young kids that you can choose to form a team of 6. And second, yes, it's their culture. So I I didn't see that I didn't see that much from the math olympiad. But then if you think about like how they train the kids for, let's say, the sport, the olympic sports, it is pretty hardcore, and they do train the kids from like from very, very young. And a lot of the times the kids, like even during their teenage times, they spend a lot of times doing the sports training. And and of course and all these things are public knowledge, like there are even documentaries or like articles that talk about this. So I think it's also it's therefore fair to assume that they would do the same thing for math olympiad.
So later on, when you went back to Malaysia,
Yeah,
was math easier there?
I think I didn't really look I I I didn't really think about it at that time, but now looking back, I do think yes, the math is slightly easier in Malaysia at that time.
And in Malaysia, so how does the selection take place? Is it like you are the best at math in your school, so you sit for the national test, and then you start from there?
I think I think for school selection it really depends on school, but then for us, because we didn't really have a good idea on, like, I mean, well, the teachers and the teachers and the school didn't really have a good idea on like what it takes to do the math olympiad. So they tend to just select students who do well in the math exams. And at that time I was chosen. And if you're asking like how the Malaysian IMO team was selected, so it all started from the National Math Olympiad at that time. Although, as I know right now, they have a different selection system. That was like what, almost 10 years after I retired from the IMO. So in 20, sorry. So after that, those who did well in the National Math Olympiad will do an extra selection test. that I think that will involve like
And
around like
and
yes, sorry.
at what age do you start doing the Olympiads?
I think that was 14. So when I was in grade 8.
14 years
Yeah.
old?
Yes.
Okay. So and what was your age when you got the gold medal?
18.
So after 4 years.
Yeah.
Okay. Um, so say someone wants to prepare for the Olympiads.
Yeah.
Um, and did you depend more on your personal work or on the Malaysian preparation for the national team?
Yeah, I think it's a combination of both, honestly. So I do think that the exposure to the Math Olympic camp, that definitely helps. It just tells us like, okay, I think on knowledge wise, you get to learn like, okay, what are the new techniques that you don't learn in school, what are the identities, what like, and also as I mentioned just now, the proof writing techniques. These are the things that you don't learn in school, and that it's pretty important to know what are out there now. And the other aspects of the Math Olympiad training camp is the environment at the camp itself. So you basically get to mix with the like-minded people. I mean, it. I mean, to be honest, there's some sort of competition going on, because you have like around like 40 to 60 students in the beginning, and everyone is basically fighting for the 6 spots for the IMO. But it's in the end, it's more like collaboration, friendship, more than the competition, because people would just want to take it easy, and this is what I really like about the Math Olympiad camp. And in fact, we talk about math a lot during the camp itself, but we also do a lot other like social activities, like playing poker cards and whatnot. So that's and in fact I'm still like good friends with like a lot of them until today. So that's another that's the influence on the Math Olympiad camp for me. Okay, so I think personal wise, I them I would say, yeah, there's also there are also like elements on like some like personal effort as well, because after all you have like so many people, and how do you like what makes so many people, like 40 to 60 people, and then what are the things that would make the six that stand out in the end. So I do believe that we have everyone in who did the IMO before, we had and or rather like everyone who did the IMO and at least got a decent result like on the honorable mention. I think everyone did dedicate a non-trivial effort in preparing the Math Olympiad. So for example, like when you during the selection camp itself, or sorry, I mean, even between the camps, we were assigned like reading assignments and also some problem sets which we name it as homework to solve. So this do take up quite a bit of time, and after the top 6 was selected, and we get into the final trainings, there are there are also there are also homework as well, which we also call it as the mock IMO, and in fact that also got intensified, as in we'll need to attend the problems every week, and we attend the camps every week as well. So that's, and we also have to do like have to like on our own interest dig up other problems to solve it on our own and as practice, and also to read other more advanced knowledge that the camp might not have covered. So yeah, I would say it's a combination of both the training camp and also like your own initiative. And of course, I should also mention like the support from other people around us, like especially the teachers, the parents. I think that also helps a lot, I would say.
Yeah, I have a question about your parents. I'll go back to it later. But
Okay.
can you give me more details about the preparation, the Malaysian preparation? How many times is there a camp per year? What are the homeworks? How long are they? And
Yeah.
how long is normal preparation camp? Is it like 1 week, 2 weeks?
Yeah. Okay, so there are four camps that for preparation and selection camps during my time, and each one lasts around 5 days. So the structure will be something like in the morning you have you have two lectures, and in the afternoon you have sorry, in the afternoon you have a daily task, and at night we still have something, but it's supposed to be like more relaxing. It's more like problem solving session. So that's like the rough structure of the camp. And of course the schedule does shuffle around. So for example, for some days in March and in April, for the uh, so a typical math Olympic camp will end in a and at noontime. So like right before that, the last program would be something like instead of two lectures, it will be for example in March it will be just the APMO, the Asian Pacific Math Olympiad, and in April or in May we did the International Math Tournaments of Towns, the IMO. So these are the decentralized international competitions, and they were also factored pretty heavily into the selecting the final six students. Now, as of the final training camps where only the six people who would represent Malaysia would attend, we have no we have like what the it's mainly on a weekly basis. So like every week we will travel to uh, uh, like the students from different places will gather at the same place, and for a weekend, and then we will have like a we will have like a 4.5 an IMO style exam in the or rather like practice test in the morning. So that's like 4.5 hours in the morning, and then afternoon and nighttime there will be that there will be problem solving session, and sometimes lectures if there are lecturers available to give lectures. Now, regarding homework, it really depends a lot. So I guess it's also fair to say that in the beginning the okay I think for length again it could vary a lot for different training camps, and also depending on who runs it. For most of my time, there were only like two problems for you to solve throughout the interval. By interval, I mean like by between the two consecutive camps. So that's probably like 1 or 2 months. There are only two problems. However, I should
Excuse
mention.
me.
Sorry.
You're saying that you only had two problems to solve in like one or
Yes.
2 months.
Yes. I mean there are exceptions here and there. Sometimes you have four. Sometimes you get like a whole list of like say like 30 to 40 problems, and you are supposed to choose a few. Now
So
that being said,
excuse me,
yeah,
is the idea that you only have two problems to focus on? Is it like it's
yes,
okay to spend 1 month with a problem and everything else is fine
yeah,
else?
yes, that is the idea. So yeah, so that's where the next interesting part comes in. So in the beginning, the
And these
two
are like IMO problems.
yes, yes, yes. I guess I could yeah I to illustrate, right. So in the beginning of the camp, say like in the first or second selection camp where we have a full force of 60 people, there the problems tend to be easier. So maybe you get like some IMO problems on on the easy scale. So for people who already did the IMO, you basically would only spend like what like a few hours on the problems itself, and after that it's up to you to like do other problems as practice on your own. When you get to the final stage of selection, not the top six, but when there are like 12 students left, you tend to get harder problems on the problem set. So in fact, there were ones where we got two problems on the hard end of the shortlist. So meaning like so meaning that is like what, A7 and N8. So and that's like that's the last one on the shortlist. So I still remember at that time, even the students who made to the who got medals in the past IMOs, they couldn't solve the problems. And I mean, I mean the stronger students, well, they still submitted something, and as partial solutions. But this just goes and show that how having just two problems doesn't mean it's easy. And in fact, in fact, a lot of times for those problems, other than a few who were like past IMO medalists, others tend to like get like very like minimum score, to the point where even getting some not getting a positive score would be good, would be would be good enough to get into the next round.
So your
Yeah.
preparation is the philosophy of your preparation is mainly focused on mental strength. It's like you have one problem, you have a lot of time, think about it. It's like, especially do not look at the solution,
Yeah.
and the goal is not to solve it. The goal is to think. So is that it?
Yeah. I think for the homework, yes. But for the especially when you get like when you get like some like crazy hard problems, yes, that is the philosophy. But realistically, you still want to aim to get at least a non-trivial progress in for any like IMO problem within a reasonable time frame, because after all, for in the IMO you only have like a few hours to work on the problems.
Mm-hmm.
Yeah.
Is there a specific way to measure your progress apart from being able to solve harder problems?
Uh I, I okay, I would just be honest in saying that, yeah, that's the main way I measure my progress. And of course, and also based on my based on my performance on the test, or like other exams like the Asian Pacific Math Olympiad and whatnot. I think another thing would be like how easy I can understand the solution of of math Olympiad problems, I would say. So by understand, I mean like not just following the logic, but also like understand where they come from. Like for example, you see sometimes you see that there are some problems where it's like, okay, the solution is extremely easy to understand, but it's so hard to come up with. So if you still remember the windmill problem from 2011, that's like one of the notorious example. So being able to get those intuition, I think, is also part of the progress. I was saying like how like besides like solving the problems and getting scoring better on the test, or like other math Olympiad competitions, like being understand the intuition, following the logic of of the solution, is, and of course like knowing more things, they are also part of the progress, I would say. Yeah.
Do you think it is as important in your progress journey to learn new techniques, or just to master what you are with the techniques you know? Because you will find people thinking about learning projected geometry while
Yeah.
they still need practice for angle chasing. So what do you think about that?
Okay, I think, yeah, I would say both are important, like mastering the techniques and also learning new techniques. But regarding to what should be your priority, I would say that, yeah, I don't have a good advice that works on everyone on saying that, okay, you should focus on this one or you should focus on that. Um, but I would say like, once you get pretty comfortable, I would say that mastering the techniques you learn is probably more important. Like for example, like the things like angle chasing and like what, like finding similar triangles, that the basic techniques. Now, once you think that you get very comfortable with it, by comfortable I mean that, okay, you see this problem, and once you, for example, for geometry, you, once you draw the diagram, then you know, okay, this is an angle chasing problem, and then you start chasing the angles, and you probably and then you probably notice that angle chasing won't cut it, so you see what other techniques you can use. So in this case, you can be confident in saying that, okay, you have like, I wouldn't say master, but master the technique, but more like you get really comfortable with some basic techniques, and then now you can start exploring other techniques that people have used.
So, how would the preparation translate into a number of hours? Sure. So, I said, how many hours would you spend working on math Olympiad problems, whether you are in a holiday or going to school?
Right. uh, I think I'll just put it this way. So the Math Olympiad can, they helpfully quantify this question for us during the 1 day seminar already. So if you are just counting, like, if you are just counting the the hours we spend on writing the tests and the practice problems, attending the camps, that would amount to around 200 hours. Why? Because, like, okay, in the beginning it's probably not that much, but then once you get to the final stages, um, you have you have like the mock IMO, the IMO style exam, and that is for 4 hours and a half. And sure, for each cycle you will probably get like what, 20 to 25 of them. So that will easily add up to almost 100 hours. Okay, and then outside of that, we probably spend a lot of time on, like, yeah, cracking the homework problems, and also just to do some like fun readings ourselves and cracking other problems as well. So I would say it's safe to assume, not to say assume, it's safe to estimate that around maybe like 500 hours per cycle. By cycle I mean like, I mean by bicycle I mean 1 year. So yeah, that's and cumulatively throughout the 4 years, I guess that will be around like 2,000 hours. I don't know. Yeah, that's just my estimation.
Is that normal for you that during, I don't know, physics session or a geography session that you work on Olympiad problems in
I
secret for
mean,
sure?
yeah, I mean, it's easier to get distracted in the class as well. Like sometimes you get some not so interesting subjects, like how, like some what you sometimes you get some parts of, say, the history class that you don't really like, and then you just drift off and do math Olympiad problem. I mean, yeah, that yes, that happened before.
What is so impressive in your IMO journey is going from honorable mention to gold medal.
Thanks.
That's so inspiring.
Yeah,
So the first step you did is going from honorable mention to a silver medal, and then
yeah,
from a silver medal to a gold medal.
yeah.
What was the tweaks or the changes that you made to go from honorable mention to a silver one and then to a gold medal? Is it just like you kept doing the same thing again and again, or were there major mindsets that you acquired or changed during your journey?
I think I would say that the first time when I got honorable mention, I think sorry, I think at that time I was just like like bogged down on like okay trying to like practice solving more problems, and then and not and how should I phrase this? Shortly before the IMO itself, when I talked to my teammates at that time, I started to realize that okay, there might be some gap of knowledge that I had. So okay, I don't have a good example for other topics, but then for geometry, I think at that so as of that time, I only know things like the basics like angle chasing, and whatnot, cyclic quadrilateral, similar triangle. So I think basically everything that you can do with angle. So in particular, things like what the like trigonometry, poles and polars, inversion. That one is kind of out of reach for me. Um, and I mean, of course, it just happened that that time that for that year we didn't have a geometry problem on the easy category, but still that's like the level the level that I had at that time. So of course, so it wouldn't be surprising that I didn't get a medal at that time. And after that, I would say that I started to, I mean, after that, I would yeah, I continue to solve more problems, but also I also try to like enrich my knowledge. So for example, by reading some of the the sample solutions of the some like IMO level problems. So for example, I learned at that time like what the Hall lemma is supposed to be. So Hall lemma is something in combinatorics, which talks about perfect matching, and I think it's mostly on spending more time, and also like and also just like keep doing the problems, and like and close the gaps of knowledge. I think that is what work for me. Yeah. Going from silver to gold
Do you
medal, I
actually
think. Sorry, go ahead.
do you actually think it's
Yeah.
a good idea to read solutions?
Uh that's a tricky question. I yeah, I think really depends on the philosophy of different people. So I think I would say like for if you are doing problems that are like comparable to your level, then it will be a good idea to like try to solve like spend as much time as you can within a reasonable time frame, and then once you get stuck, then you can start reading maybe reading like the first two lines of the solution, and see where people are going, and then continue trying.
What
If you are
is
reading,
reasonable? What is a reasonable amount of time?
I don't know, maybe like maybe like 1 week or something. Yeah.
Okay,
Yeah,
got it.
I guess if you are doing something that is like very difficult. So for example, when you are barely like say like 1 year into math Olympiad, and then you are faced with this the like some crazy IMO problem six from the past that only five people got it in the contest, then yeah, I would still think it's a good idea to like think for a few think of the problem solver for a few moments, and you probably won't get it, but then you get a better hang on what's going on, and then that's the time then that's the time you can start reading the solution, because if you just jump into the solution right away, the chances are that you won't understand anything. Yeah, that's just how I see it.
Okay, I let you go on with the transition between a silver medal and a gold medal.
Yeah, I think that is probably more nuanced, because I I would be honest in saying that like after my second IMO where I got a silver medal, that at that time you start to experience what we call as the diminishing point of returns, as in like you keep you kept trying you kept trying to to do problem solving, but then you don't really see an improvement, because I think at that stage, right, trying to improve, it's like learning how to improve just got harder because you need to actually you need to like actually jump out of the of your own comfort zone, which I'm not sure actually if I still I actually already achieved that. um I think, yeah, I think it part of it might also be like contest preparation, or like contest preparation strategy, or just how should I phrase this, contest preparation strategy, or like contest writing techniques on like where, okay, like how do you strategize your, like given your knowledge, given your skills, how do you strategize during the contest itself. I think that comes with experience, and you can only get better every time you do it. So I think that's the main thing that helps. And other than that, it's mainly just like practicing doing more problems, and also like digging up stuff to read. I think, yeah, that's the main, that's the main thing. Nothing, yeah, nothing too magical, or or, or anything like that compared to the first transition. Yeah.
From where do you get your problems? Do
The
you have
problems.
a specific book or specific website that you like the
Uh,
most?
I think the IMO shortlist itself already have has like a really good list of the problems to work on, and there are just a lot of them. It's you'll never run out of them. And of course, other things like the US AMO, the what US AMO, APMO, all these things. Yeah, it's fair to say that the contest collections itself is a good resource to work on. We do also have the textbooks, which is titled Problems from the Book. So that um, for that collection, we do learn like a bunch of like different techniques accompanied by the practice problems. So yeah, that's also a good way to spend our time at.
Is the textbook exclusive to Malaysians or is it online?
The textbooks. Oh, I think the camp actually like landed us the book. So yeah, I mean, it's like during the selection camp, we do get to when we were involved in the selection camp, we do get to read them, and then we just have to return them after the IMO.
Okay. So basically, the answer from going from honorable mention to a gold medal is just practice. Practice from the short list of IMO.
Yeah, I would say, yeah, practice in general, and yeah, and also try to expand your knowledge as far as you can.
Did you still learn new tricks when you moved from the silver medal to the gold medal? Were there something you were
Yeah.
not aware of, or?
Oh yes, that's for sure. I couldn't quote an example right now, but yeah, that definitely happened.
And do you have a personalized copybook where you take notes of the tricks or the strategies that you discover yourself?
Yes, I think I do have some notebooks at that time.
So, say you're faced with a very challenging problem
Yeah,
that you could not solve for a while, or you know beforehand that it's very challenging. It's like
yeah,
P3 or P6 of IMO.
yeah.
What is your approach? How do you start?
Uh, yeah. I think if you are in a contest itself, then the strategy is it's like just do it. uh, and
Just do what? Sorry.
just do it. Just do it.
Okay. Yeah.
I
So,
think, yeah,
by doing it, because I see I see that. I mean, I see two approaches when you have a problem. Is that you read the problem and you get inspired by the problem and you start applying tools, or you
yeah.
already have tools in your mind that you want to impose on the problem. And another way is just forgetting about the problem and getting curious to understand what's going on.
Yeah, I think the first one is probably more useful in a more utilitarian sense, as in like because during the contest you have very limited time, so you want to just apply the techniques that you have and see what happens. Well, the second technique would come handy when, like for example, you ran out of ideas and you just or maybe you just didn't know like what you could do in to start with. Then you'll try to see, okay, what's going on with the with the problems, and try to paint a mental picture on what's going on.
What do you mean paint a mental picture? Do you imagine or
Like
see objects when you're thinking of a problem?
E yes. So yeah, I think I can say an example would be something like if you are doing like say the some combinatorics problem, say you are on a checkerboard, then you'll see and then you see that okay, the problem is basically like some pieces moving, then then you'll naturally have like okay, have a scenario on like okay, how the pieces would move and what would be the so-called the extreme case in your mind, that will helpfully help you to get some progress on the problem.
Do you have any other ways of starting a hard problem?
Starting a hard problem, I think another thing would be try some small cases like for like things like when you are given like say like a multivariate inequality like n variables, then you'll start with like okay, what happens if you have two or three variables. And I think sometimes it's also worth to see what happens if you just brute force it. By brute forcing, I mean I mean something like when you're trying inequality, then you see okay, what happens if you differentiate it and then uh, do somehow like Lagrange multiplier, that kind of thing, and see where that leads to.
What was your best subject in the IMO?
I think geometry because yeah, that's I somehow discovered a trick of solving the problems using like trigonometric methods, aka like ratio chasing between between multiple different objects, and that worked pretty well in most cases. Although there are also a lot of other problems that you need many other tools.
So ratio chasing, that's the first time I hear about it. You mean
Yeah,
like similar triangles, Thales theorem?
that's a special case of the ratio chasing, I would say.
What are other cases?
It's more, it's say like you have I think another example where it's like where you have like like many different lines on the uh, or rather many different chords on a circle, and then you want to like quantify the ratio of different lines using the angle subtended on the circumference. That's just one thing, and of course other things will be things like how the ratios have to behave under say like Siva's theorem, Menelaus theorem, and all these things.
Sorry, what theorem?
Siva's theorem, basically you have like
Siva, okay. Yeah,
Siva,
Siva theorem or
yeah,
Menelaus.
Menelaus,
Yeah, okay.
yeah, yeah.
Okay, cool. Let me go back to your parents. So when you were starting the Olympiads, um, how was your relationship with your parents? Did they encourage you, or
Mm.
were they like, this might distract you from school, so better avoid it, don't invest too much time in it?
I they fully supported me. Yeah, that's for sure. But of course, part of the second I would say the second part is not completely false as well, because because there were two. I think during my third IMO, like after my third IMO in 2013, I was facing the high school public exam. So so that's a time where I had to like after the IMO, I just had to focus on the focus on the public exam, and I literally I did take a break from the IMO. That's for sure. Yeah.
Um, does it break your heart when you can't solve a problem?
Um, I think it breaks your heart even more if you couldn't solve a problem, but then literally after the contest, you realize that okay, you missed something, and that's the key to solve it. Yeah.
But if you just can't solve it because you did not know the theorem or the technique, that's an excuse, you mean?
I wouldn't say it's an excuse, but when you say like what breaks your heart, right? It's more of like, um, it's more of like you didn't perform optimally in the in a contest. That's that. I mean, because after all, like that's what a lot of IMO people care the most, as in like doing well in the math competitions. Now, I mean, of course, that being said, if it's a technique that you don't know, and or like a tech or some a technique that you know, but then like you are not very comfortable in or like familiar in applying, then you just have to own it up and say like, okay, this is the technique that is a gap, a knowledge gap, and just and acknowledge it and work on it.
Yes, absolutely relate. You get so frustrated, especially when the answer is in front of you, but you did not see it. Um,
Uh yeah, I think that is that would be pretty frustrating. Yes.
did you have any personalized coaching in the Olympiads? Who were coaching you on the team?
Uh,
I mean, their backgrounds.
we do. So we do have a few. We did have a few coaches. One of them was the head coach, Mr. Suhaimi. Like I think he was the leader during 3 out of the 4 times I was in the IMO. So yeah, he did most of the coaching, and there were of course other miscellaneous coaches as well, and some of them and many others were like guest speakers. They just came here to maybe like speak for 1 or 2 times on some very cool topics.
Mhm.
Yeah.
Are they the coaches on the for the Malaysian team? Are they former IMO students?
Some of them are, and others are uh, the professors in universities.
Um, okay. So the success that you had in IMO, was it transferable to academic and university mathematics?
Yes, for sure, because you learn a lot of the like advanced math techniques, and also having the right math mindset to solve a problem. I think that's pretty important.
So because last week I had a discussion with another former IMO
Hmm.
student, and he was like, I mean, all the tools that we learn in IMO, we don't use them later on for research or for the university. So the only takeaway that you can get is the way of thinking. Um,
That is Yeah, I do agree with the student on that, but I think the advanced knowledge that you get it definitely helps in the let's say in the first 2 years of undergraduate, because there are also some of the tools. I think, for example, I would say number theory, and maybe some algebra and also or probably combinatorics that you will use um for your first 2 years of undergraduate. Uh, Beyond that, it's again it's a matter of getting new knowledge, which I can see why like the way of thinking that is pretty important, because like uh it's not just about the math intuition, but also like the attitude, and also the intellectual curiosity that leads you to keep learning and also internalize those knowledge. And when you get to graduate school and i.e. doing research, I think that the way of thinking just got even more important, because yeah, there are just too many things to learn.
So we both agree that there are two key elements, which are the way of thinking and
Yeah.
the knowledge that you get from preparing for the Olympiads. In
Yeah.
terms of percentages, how would you divide them?
I think probably the way of thinking, I would say, yeah, that would come up to 75%, 80%, and the rest is the new knowledge that you get.
Tough. So you've had experience teaching advanced topics to other students. How has that experience been? And do you have any advice for educators who are preparing students for mathematical competitions?
Okay, if you are talking about the experience, okay, I have to admit that I'm not a very good a good lecturer yet, because yeah, I think it's always fun, and I'm always happy to like tell people like what are the techniques that can be useful in math, like especially for Math Olympiad. And yeah, and as I say, I enjoy like teaching the like things, especially those that I'm very familiar with, like for example the like some geometric techniques, the ratio chasing stuff that I mentioned just now. um Now I think the thing that I still have to work on is like how to actually make students enjoy the lectures themselves, like uh, uh, not just on like teaching them the techniques, but also the intuition. Like for example, like this is to say like now when you see, okay, this is a new technique, and then this is a sample, a problem that you I think you can apply it to, and why do I think that those techniques can be useful in this for this kind of problem. So like the intuition behind it, I think of course it's also on the students themselves to learn how to get those intuitions, but I think having someone to bridge the gap, that at least the initial gap, I think that's that will be useful. And regarding how like I was saying like it's also important for the lecture when you are teaching like advanced topics. I think like it is good to impart the knowledge, but it's also for Math Olympiad specifically, it is also important to like let the students like know where the intuition comes from. So for example, you tell them that okay, there's this technique, there's this example problem. How do they blend well together? So like what are the key elements that you see from the problems itself that you can say, okay, I think this technique would work. So yeah, that's the important part. Of course, you can also say like a lot of those things comes with experience, and then the students can only get it themselves. I think that's also true, but having someone to someone to lead the way in the beginning, and let the students figure out the path their own, I think I think that's would help the students a lot. Yeah. Now, the second part regarding the advice I have for the educators, uh, I think, yeah, I think a lot of those advice, like how to teach the students, I think the a generic advice I have is that be very like okay, be very sure on the level of the audience. I think that is pretty important, because you wouldn't want to drown your students with say like projective geometry and like complex numbers in combinatorics on all these things to a group of students who didn't even know what Math Olympiad is. That's the thing. So in other words, you want to cater your you want to cater your material, and probably also the way that you explain the things to the specific level of the students that that you have. And I think this is what the Math Olympiads camp has done in the past as well. So like at least for the in the first two camps where there are like 60 students, the students were basically divided into the junior and senior category for the same reason. And yeah, that's one thing. And the other thing would the other thing would be that I think if you are just teaching I think if you're just teaching like a generic group of students, aka the students who never know what Math Olympiad is, they just attended this because they did well in school exam. I think it will. The most important thing will be try to make the Math Olympiad subject interesting to them, so that they can get they can get interested in at least taking the first step to learn new things. Yeah, that is important. If you are talking about like how to coach rather advanced students, say like let's say like you are boiled down to like top 20 of in a national in a selection process, then I would say at that time having a team of lecturers is probably it will be important at that time. I mean, you just can't handle everything your own on your own, because yeah, just face it, you need different people with like different expertise, and it's often the time you don't have all of them unless you are say unless you are lim jack, of course. Yeah.
So how would you say a math session should be? Is it like you give the exercise to the student and then you give them a hint and then wait a little bit more and give them the solution later on?
Mm, I think that's a general structure. However, I think it's also I think what will also mm, make the process more interactive would be that, okay, so maybe like every 5 minutes, just I walk around and check like what are the progress of the students, like say in their own group. And then and at that time you can probably say like, okay, like once you see like someone has made a lot of progress, then you can say, okay, uh like here's the hint that would be useful to you. And so I think like having like like okay, personalized might be too strong, but then like hints that are tailored to like a student's progress at when solving the problems, I think that will be really that would be really useful. Unless of course it's a universal hint that a lot of people miss that, then yes, you can then yeah, you can just like announce it on the blackboard. Yeah.
Do you think it's useful when the educator and the teachers are thinking of the same problem out loud?
uh, Thinking of the same problem out loud, so as in like you are talking about you just like kind of like I was saying that it's is it a good idea to say like
Yeah, like
periodically like say
you you put the problem on the board
yeah.
and you just spit out ideas and you are thinking together, everybody.
Mm, I would say it's probably I would say it's probably useful to save that to until a bit later, so that students get their uh have their time on their own to like think of that without um,
Mm-hmm.
like without relying on the hints of other, like the educators or like other people first. Then after that, when you see like um some students are still stuck in for example, like they didn't know like what how to start with, then yeah, you can start thinking out loud. Yeah.
So, can you share any anecdotes from your four participations in IMO?
So anecdotes, do you mean like some useful quotes or something like that?
Any funny incident that happened, or
Oh,
Whatever you see fit.
okay. Okay, I think one classic ones from my teammates. So so for some context, the first time when I got honorable mention, that was 2011, and that was also the time where Malaysia got the first gold medal by my fellow teammate Hao Siu. Um, so he nailed the IMO by we call the windmill problem, which also happened at that uh, appeared at that year, which was just like unexpectedly hard, and he basically skipped that and solved the next problem, which is the third problem on the IMO, which is a functional inequality. And he classically said that for function is easy because you just have to plug here, plug there. I think the verbatim is like for function you just is okay. The verbatim was the for functions you just have to plug, meaning that you plug different values and you see whether they work. I think that's the that's the classic one that I could think of. I think other thing yeah so I think in 2014 that I would say 2014 there were a few. So first of all, like problem 5 at that time was I think was like a coin partition problem, and it was listed as number theory, but we all know it. We all know that the PSC was not doing the job. Sorry for criticizing. And that was in fact that was in fact a combinatorics problem. So so we were first of all people were complaining like, okay, why there were like three combinatorics problem, and second, like we because like the coin values are basically what in terms of like 1 over n for any for any value n. So basically you are saying that there's this country that like issues coin of like value 1, value half, value 1/3, value 1/4, etc. And people and we all just be like, don't care about this problem. No banks will actually do that. And then the last problem, like I think problem 6, that was that was a hard one. Like the like basically the whole team, the whole Malaysian team got 0. But that was fun in the sense that like that we were asked to prove a bound on square root n, a lower bound on square root n, but we the problem also helpfully mentioned that if we can prove a bound of like c times square root n. So for example, if you prove things like square root n over 2, if you prove a bound on like say like 100 sorry what square root n divided by 100, then you will get that. Then you might get some points. It is stated over there. One of my teammates, he literally had a one line on the script saying that for c equals to 0, it obviously works. So he literally told us that he's that guy is Zisong Yu. He later on he later on also went on to get a gold medal, and that was his first participation at the age of 12, I think 12 or 13, and he got a bronze medal. So that's also pretty remarkable of him. That's the funny stories that I could think of. And I guess other honorable mention of the anecdote. Maybe not the anecdote, but maybe things like how we would probably complain enough of like how the IMO was too cold in 2012 because it was in the southern hemisphere.
In 2012, you mean?
That was Argentina.
Argentina, it was
it was
Mar del
winter.
Plata.
Yes.
Are there any figures in the IMO that you look at you look up to, like mentors?
So the head coach that I talked about just now, like Mr. Suhaimi, he was the figure that like, I mean, or rather one of the many figures that I respected when I was doing Math Olympiad, because yeah, I think it's fair to say that, like, to talk when I was in high school, he was the yeah, it might be a bit too strong to say that, but he was literally the authority of math, and for me, because yeah, because I in math, yeah, I mean, okay, he, first of all, he was like the leader of our IMO team, and he was and of course it's fair to say that he's pretty knowledgeable in math, but also he was pretty dedicated in teaching us like Math Olympiad camps, and also conducting the camps, and I make sure everyone learns something, and and of course also like how he knows how to connect to the students, in saying that, okay, like for example, he did like on the first day, like before we even know what's going on with Math Olympiad, he already warned us that the the scores are supposed to be low, to be low, to the point where you can get, even if you can get half of the problems right, it's doing like very very well. So that kind of thing, and coupled with how well he can explain certain math concepts, I think that was very respectable for me.
Was that the National Olympiad?
Uh, the national. Oh, no, I was talking, referring to the head coach,
Yeah, yeah. I
of.
mean, when you said do not expect to have a
Oh,
low score,
oh
what was
yeah,
that?
no, I think that was like after the National Olympiad, when we got into when during the first day of the selection camp, where they were like, I think that there were like 60 people who were part of the selection. I think that's like the venue where he gave the presentation. Yeah, so
So, yeah.
yeah, I think that's one of them. And for others, maybe some of the more senior IMO teammate, for example, I think I can quote one. He's called Taming Hong. So he when I first joined, he already got a silver medal the year before, and that was the yeah, and yeah, he was also like pretty nice and like pretty helpful in helping the more junior Math Olympiad students. And there are of course other, like other people in the team that I look up to, like many those senior folks. Yeah, so those, and of course of course the trainers as well. But I think Mr. Suhaimi, yeah, he was the one who deserves a special listing. Yeah.
That's pretty fair. Do you still do Olympiad problems today?
Uh, yes, but mainly for fun, and of course, because also I'm like, I wouldn't say coach, but then I sometimes do give some like guest lecture to the Math Olympiad, the Malaysian Math Olympiad teams, from time to time. So yeah, I do attempt the problems as well. Yeah.
IMO 2023 is pretty close.
Yeah.
Do you have any advices for the contestants? Do you think it's a good idea to keep practicing till the last day?
I would say that for the last day, they should probably just unwind themselves and make. It. I guess sure. Like, in the big, like in the morning, they can still, like, okay, try to like read up some stuff, but probably they should just like relax themselves, and like I would say the cutoff point will be the opening ceremony. Like after the opening ceremony, which is presumably in the afternoon, they should just at night they should try to sleep early. And it might be useful to, it is okay when you, if you have already something in mind, and then you just want to like just finish it, that is okay. But just try not to like pick up anything new. That's not gonna that's not going to help, if any, that could even make you more anxious, and it's not going to, it might lead to suboptimal mental state in on the next day. Yeah.
Do you have any rituals before the exam?
Probably just meditation. Yeah, I
What
think, yeah,
what
it's
what
also,
type of
yeah, it's
meditation?
also like, I it's also worth mentioning that one of my teammates, his father is a doctor. I mean, he was a doctor at that time, and maybe he has retired now, but anyways, yeah, he taught, I think the father actually like um attended one of the training sessions, and like just taught everyone how to do meditation. So it's like, you just just close your eyes and then do some like deep breathing for, say, like the 5 minutes.
Can you teach
Yeah.
me?
I think, there's nothing too deep. I think it's just like, yeah, just not think about any, and like just try not to think about anything at this point, and then yeah, that kind of, imagine that you are not you're not doing anything now, and you are literally in the nature, in the farm, and yeah, I'm just making this up with yeah, the 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 quotes, but yeah, you get the idea.
So you do this before the exam or during the exam?
Before the exam, yeah, like right before the exam, like you are, I mean, you get your seat, and then you know that there are still, like, say, 10 minutes before the exam starts. So yeah.
Do you ever get ideas while you are doing something else other than math? The math.
Do I ever get some idea when I'm not actively doing math, you mean?
Yes, like when you are meditating.
S- Wait, so sorry, can you repeat the last one, because
I
it
mean, ideas for a problem you've been thinking about.
uh I
Yeah.
think,
So,
yeah, like sometimes,
mm,
yes. I mean, okay, I think the entrepreneurs or like the billionaires like to tell you that sometimes the best idea comes when you're in a shower or when you're in a gym. I think, um I don't have like, I don't have a strong evidence on that yet, but sometimes that do happen. Like, so for example, like sometimes when I was playing piano, or sometimes when I was like in the shower, that some nice idea do come by, and that could be, I mean that's useful when you're just solving the problems on your own. For actual IMO itself, I think, like, people talk about like taking a washroom breaks, once in a while, and sometimes it did help you to get relaxed, and then I think at least once or twice the some good ideas do come by at that time. So yeah, that's a some good examples. Yeah.
you mean uh, you mean you get some ideas when you are playing the piano or when you are on walk, right?
Yeah. Yes.
Um, did you ever looked at the problem and then saw the solution very rapidly somehow, and then you were trying to get it back in your head and chase the traces of the ideas that you just show, like you see it very rapidly like flash,
Yeah.
and
Yeah.
then you try to go back step by step. Does that happen to you?
Ye- yes. Yeah, it did. Although I couldn't quite quote an example on what happened, but yeah, it surely happened.
Yeah, I'm mentioning that because it happened to me once. It's like you get very strong intuition about what's going to work, but you
Yeah.
don't know why at first, and
Mm.
then it turns out that it's actually the solution.
Yes.
So, during your IMO journey, did you ever go to dark places mentally, like thinking about quitting or thinking that you're not good enough?
Uh, Not exactly, but I do. I think at how should I phrase this? I think some of there are sometimes I just don't. I mean, I just don't get. It could feel pretty frustrating when you are like not making progress or when you think that you are not improving. I think quitting might be a bit too strong, but then but then there were probably times where just I just thought of like, okay, I don't feel like I want to like grind as hard as I did before, and maybe just probably just like probably just like how should I phrase it? Just go with the flow and see what happens. Yeah, so yeah, that did happen before.
Um, Let me go back to a previous question about the rituals. So you mentioned
Yeah,
that meditation. Do you still
yeah.
do that today?
Rarely.
Um, what else? Do you have any other rituals?
I think probably things like yeah, just going for a walk or just going for a run, or just or just like I think at least like taking a break from your say like current research. I think sometimes that does work. Yeah, by taking a break, I mean like,
D-
or maybe just like hang out with people, or okay, that's probably not that's probably not a ritual, but yeah, you get the idea. Or just maybe just go play some piano. Yeah.
Do you take something to eat inside the exam with you?
Um. Uh, I don't quite remember. I don't think I got something to eat, but I probably consume more water than I normally do.
Do you have any special diet, or you're just eating whatever?
Yeah, I don't follow. I don't have a special diet for the competition. I was yeah.
So to sum up, the rituals is get enough sleep
Yes, for
and
sure. Yeah,
meditate and
yeah.
disconnect from the Olympiads one day before or the night before.
Yes, I think getting enough sleep is probably pretty important, especially for people who are traveling to different time zones. Yeah,
How many hours do you sleep?
I think I still have a healthy like 7 to 8 hours usually.
Mhm. So other than mathematics and Olympiads, uh, what books do you like? What music do you listen to? Do you practice any sports?
I think for sports, I don't intentionally play sports, but I mean I do run. That's my main sports, and during winter I go skating on the on the ice rink. Yeah, that's basically just as a hobby. For music to listen, I yeah, just there it my choices of music are just all over the place, but uh I think yeah, but classical music definitely is has a place in my heart. Yeah. Other things that I do, yeah, probably just like hang out with hang out with friends, and yeah, and as I say just now, like just run piano, and then that's mainly the things I did. Yeah.
Why did you choose Waterloo?
Why that for the scholarship, I guess.
But weren't you able to get, I mean, with a gold medal, I would suppose that you can get a scholarship to any good other university in the world.
Uh yeah, that's a good question. So like, I think for if you are talking about the UK, I there as far as I know, they aren't that generous for scholarships. I mean, that's just my knowledge, and you probably will only get scholarship if you are like not just a gold medal, but then like maybe like multiple gold medals, like and close to like perfect score. So I think I think Alex Gunning might have gotten that kind of scholarship before, but again, he had a perfect score on the IMO. But yeah, that's just what I mean. I didn't know I didn't know the details, but that's just what I heard. What I heard of. Um, for the US, it's mainly based on your. I mean, at least the top ones is basically mainly based on your the family income, and so which means that it's like it's financial, it's like need based financial aid. Um, I recall yeah, for some reason I didn't get that much of financial aid at that time. Yeah, so I mean, not because my family is rich, but then I think that there might be, yeah, that I'm not too sure what's going on. So yeah, yeah, I just thought that okay, for, like Waterloo is probably it's probably the best choice given the situation, the offers I had. Yeah,
And now being at Waterloo, do you recommend it?
yeah, for sure.
So, do you think that, I mean, from what you've just said, what you're saying is that even having a gold medal in IMO
Yeah,
does not
yeah.
guarantee you getting into a top university or whatever university you wish to get into.
Yes, because there are a lot other factors they look into.
But today you are doing a thesis at MIT, right?
Yeah, yes.
Do you think your gold medal played a major role here?
Mm, yes, I mean, okay, I would say yes in the sense that like it wouldn't like having a gold medal will not like directly get you into MIT because they care more about like because IMO after all like having a medal that was a high school achievement, and then they care more about like what you have done most recently, aka during your undergrad. Um, so but I do think that like having a gold medal did it, or like or doing like math Olympiad at all, like it did help, as I said, it did help me to like get get uh like learn math in at the college level like more quickly, and it also helped me to find my interest in doing research, and that's probably what the graduate school cares more, like aka the ability and the interest to do research.
So, what is the next step for you? You want to become a PhD student? I mean, you are a PhD student.
Yes, I am.
So what's next?
uh I haven't decided what would happen after my graduation, because yeah, I'm a second year and there's still a long way to go. I think a more immediate goal would be like to just simply just get better in doing research, and like just and get and like get at least a few like really like very good quality papers out. That's the more immediate goal, and what happens after that, I think yeah yeah, that's the yeah we'll see we'll see what happens.
Do you drink coffee?
Do I drink coffee? Yes.
Do you drink it to get like more focused and smarter during
um
an exam or a special event?
Probably just to stay focused. Yes.
Would you recommend drinking coffee before an exam?
uh I think it's a good idea for if you are used to drinking coffee. If it's like you don't drink coffee regularly, or okay, or in a more extreme case, you're only drinking like very once in a while, then I would say don't alter your diet, because because one other thing about coffee is that okay, it can make you stay awake, become more focused, but it can also like increase your heartbeat and make you more anxious if you don't if things go wrong.
Yeah, exactly.
Yeah,
I personally avoid it when I have a big event or an
yeah,
interview.
yeah,
For that reason, even though most of the time I just feel more focused and more present. Something else that I avoided is that when I get to an exam,
yeah,
for the IMO, so being a
yeah.
former IMO contestant,
Mm,
I also avoided taking anything sugary with me because after
yeah,
eating something sugary, I would feel sleepy.
yes, that's
So
for sure. Yeah.
I would avoid that.
Mm.
Well, my last question for you is what advice do you have for aspiring students? What advice would you give to students who are aiming to compete in the IMO or
Mm.
other similar competitions?
Yeah, I think
And let's have it per category. So for beginners, intermediates, and advanced.
I think for beginner it's like I would say for beginners like it's like give yourself some time because it will, yeah, just realize that it will take at least a few years in order to be good in math Olympiad. So this is also to say that if you are starting at say the age of 18, that's probably not a good idea. Yeah, that's just my personal experience. Mm, but yeah, if unless you are like actually like very I mean, okay, if the goal is getting in, that's if the goal is getting into like IMO. If you just want to like do math like true for your own passion, then yes, this by all means go ahead. You can probably find your place in college level. But yeah, for beginner, I think besides giving yourself some time, it's also try to like master the basics as as far as possible. S- mm, Now, if you are getting into the intermediate, meaning that you can at least get some like nail some
Excuse
of
me.
the.
What would be a good place to start for a beginner? You said master the basics. How can I do
Yeah,
that?
I think out of problem solving has a lot of good problems. So uh now that being said, it's also important to understand like it's how like what are the problems that are suitable, or like or simply the reading materials that are like suitable for the students. So probably doing some research on like on like the level of difficulty of like different, say like different contests, or like different math Olympiad camp. That would be, yeah, that's yeah, that would be important. So things like I will just quote one example. If you're talking about the US, then maybe things like the AIME, or like American high school math math competition, or like American invitational math competition. I think that is the good place to start. US AMO, I think you can, yeah, it's better to leave it for a bit later. Yeah. So yeah, that's beginner. I think, yeah, if there's some books, I think that's also yeah, that will also be great. I do know that the head coach, Mr. Suhaimi, he does pub he I mean, I bought his books as like he had a like he had books like each one on each category, so like algebra, combinatorics, geometry, number theory. um yeah, I did buy his books back then, and that was pretty useful for me as a beginner. Yeah. And as far as I know, there I do yeah, there's one like like former IMO student who's also publishing a book. So yeah, that's, I think, if you can get those resources, it's also pretty, yeah, it's also pretty good. Yeah, for intermediate, how do you define that intermediate?
Someone who went to the IMO once, he may have gotten nothing or gotten honorable mention.
Right. So I think at that time you should probably know what you know and what you don't know. That's, yeah, it sounds very generic. So mm, yeah, I would say so that's the stage where you want to fill in some knowledge gap, especially the critical ones, as fast as possible. So by that I mean like, okay, so if you know, if there are something that comes up, that could be, that could come up on the, on like, even on a problem 1 or 4, and you are not familiar with with the technique, then yeah, that it's pretty important to like do some practice on that area. and and at the same time you can also like venture into some like slightly harder categories of problem that requires more, like requires new tricks or new knowledge. And that's where you want to also want to like say like diversify your your the say like the resources that you get from. So it could, maybe, so okay, what I'm one example would be that maybe you just keep going to like out of problem solving, or and just browse those the same the same topics again and again. That's, yeah, I think that will be useful to for you to like keep practicing and master those techniques. But I think at one point you also want to see like what are the more advanced things uh, more advanced things out there. So, or rather like the things that you never thought of using. So I think, I've, if not mistaken, Evan Chen, he helpfully compiled a list of knowledge that that the students should know. And and even, yeah, he has a pretty like well established Math Olympiad website, being a former gold medalist himself. And yeah, he did categorize each like each techniques, each trick into different categories on like different levels, on saying that, okay, this you should know this as a beginner, or things like, oh, you shouldn't be too worried about this unless you are already like pretty advanced, or stuff like that. Yeah, so that's yeah, so like expanding knowledge, and also like just keep doing what you are keep doing what you're doing. I think that's the right thing to do for an intermediate. Yeah, once you are, yeah, I think for advanced level, yeah, that's a that's a tough question to answer, because yeah, I think I mean, uh yeah, I think I'm I'm barely at at that level yet. I feel so. But I think, yeah, I think that at that level people tend to like, yeah, just try want to like, oh, like learn some like really obscure techniques, and maybe and see like how they fit into some like really really deep, like really difficult math Olympiad problems. I think, yeah, to some extent those work as well. So I think, yeah, I think a way is to like, yeah, maybe that is to like, okay, how should I phrase this? Yeah, just be really get out of the comfort zone and learn something, like if like learn even more new techniques that you are probably afraid of, because it's like too hard and you cannot understand. So, and then try to like revisit those those things. And yeah, that can, yeah, that can really do you wonder, I feel. Yeah.
You mentioned obscure techniques. What are examples of that?
I mm, maybe things, I guess things like what, like complex numbers for geometry, because I mean, okay, maybe someone at a more an intermediate level would also use that to solve IMO problems. But yeah, this is something that I still don't, I never applied it before. And of course, maybe things that how should I phrase this, like uh maybe prime number theorem in number theory, because yeah, again, it only show up in like very recent IMOs, not even the IMO, I mean the IMO shortlist. So yeah, that kind of that kind of techniques. And
What
or
is the
maybe
theorem?
things, the
Can
prime
you
number
talk more
theorem.
about the prime number theorem?
Yeah,
Like
it
what?
says like the like as n goes large, there will be n divided by log n prime numbers in the range of 1 to n. I think recently they also, the IMO shortlist also introduced like using integration to solve a bunch of inequality problems. Yeah,
Oh,
that's
really?
also, yeah, that's like,
Surprise!
Yes, it is.
Cool. So we are at the end of
Yeah.
our discussion.
Yeah.
Thank you so much, Anzo, for
Yeah.
being here and providing
Yeah.
all those valuable advices.
Yeah. Thanks for having me.
Sure, the pleasure is mine. I wish you good luck for your
Yeah.
thesis,
Thank you.
and may we meet again.
Yeah.
Thank you, Anzo.
Yeah.
Goodbye.
Bye.